NOT gate using transistor, as I cannot make any circuit with a diode that can work as a NOT gate, right? So I need to use a transistor to make a NOT gate. The circuit diagram is like this. This will be A, this is 5 volt, and here we will get the output from this point. So for the calculation, I already have some video of this circuit. Okay, if you want to make a NOT gate using a transistor, or if you want to use a transistor as a switch, then you need to use this transistor in the saturation region. Okay, and for the saturation region, the one simple formula I'll give you, RB is equal to beta into RC. Okay, what you need to do, you should take the value of RB should be less than beta into RC. Then this transistor will work in a saturation region. Here I have a transistor, this one. Okay, here I take TN2222. Okay, in your examination you will get the transistor BC547. Okay, both the transistors look similar, but here in Taiwan I didn't get BC547. That's why I just take the similar looking transistor with a similar kind of beta, TN22222. Okay, this one. What is the difference between these two transistors? The only difference is the pin configuration. For this transistor, this one is the collector, this one is the base, and this one is the emitter. Okay, how to check this one? Just you can see here, one surface is a flat. Okay, this one is a flat, this transistor is a flat, and this one's just curvy. Okay, so just face the curvy side to you, and then this one will be the collector, middle one will be the base, and the last one will be the emitter. Okay, but for BC547 it will be just opposite. For BC547, this point will be collector, this will be base, and this will be emitter. When I will edit this video, I will show you the pin configuration of TN2222 and BC547. For you, this pin configuration is the most important thing. Okay, so for this one, I already told you the left one is the collector, right one is the emitter, and the middle one is the base. Okay, so here you can see this is the collector, base, and emitter. So first put this circuit here. Okay, now emitter should be grounded, so I just put this emitter to the ground, no problem. Now here I will take RC will be 1 kilo ohm and RB will be 100k. For this transistor, beta will be less than 100. Like for the BC547, the beta will be around 350. So you can easily take, if the beta is 350, then if you take RC is 1 kilo ohm, you can easily take RB is 100k. Then this transistor will work in a saturation mode. Okay, so here I take this resistance. Okay, in this resistance you can see this is a 100k resistance. Why? The first band is the brown, second one is the black, that means 1 0, and the third one is the yellow, right? Yellow means that 10 into 10 to the power 4. Okay, so that means 100 into 10 to the power 3. That means this is a 100k resistance. Okay, so just connect this one with the base. So the base is the middle one, right? So I just connect base. Connect 100k with the base one. Okay, I think no problem. Now RC is connected with the collector and the 5 volt source, right? The first one is the collector, so I connect collector with the 5 volt source. Okay, and I need to check the output. For the output, I can check with the multimeter. So I need to put in the collector terminal, or what I can do, I can connect a LED directly through the collector. And for the switch, what I need to do, I need to connect A with this 100k resistance. Okay, so this one is a now switch. Don't think about this is on or off now, as I didn't connect this switch yet. So this switch now is A. We already know that for the NOT gate, if this is A, this is A bar. That means if A is 0 and 1, then Y will be 1 and 0, right? 0 means 0 volt, 1 means 5 volt. Okay, so if I put this one in the 0 ground state, then output will be 1, right? You can see the LED is 1, and here you can see the 2 volt. Why 2 volt? I already told you, as this is there is a current flow through this LED, right? If I take out this LED, you can see the output is 5 volt. Okay, now I just want to show you the output 1 or 0. That's why I just connect this LED. That's why it's 2 volt. Okay, now I need to connect A to 1. That means connect to 5 volt. Then output should be 0. Let's see. You can see when I connect A to 5 volt, that means I give 1 to A, output should be 0, right? You can see here the LED is turned off. That means the output is 0. And in the multimeter also you can see this is 0 volt. Okay, so for the troubleshooting of this one, first what you need to check, here when you do the circuit diagram, at that time you already saw that the LED is turned on if I remove this one. Okay, if you saw that the LED is not turned on, then what can be happen, if I just short collector and emitter of this transistor, you can see LED is turned off. What I did, I just short collector and emitter. That means if the transistor is burned, if the collector emitter is short in the transistor, then LED will be turned off. This is the first troubleshooting. Okay, another one, transistor is working or not. How you can check that one? We all know that the voltage of base to emitter VBE should be around 0.7 volt, right? So if you just remove this one and connect to this to the base, you can see the VBE is 0.66. Why 0.66? As transistor is turned on. Why? Now I provided 5 volt to A terminal. 5 volt in A terminal means there is a current flowing through the base, right? That means the transistor should be turned on. If the transistor is turned on, then the voltage VB should be 0.7. Here you can see 0.7. Okay, so the transistor is okay or not, you can directly check by measuring the voltage VB. If VB is 0.7 volt, that means your transistor is completely fine. This is the first troubleshooting. Another one, just like in the AND gate, I told you, check all of the connection properly, like the resistance is connected with the collector or not. If the connection of resistance in this collector is not okay, that means there is no power source to this transistor. Okay, how you can check that one? Suppose someone did this mistake and put this one, and you can see here LED shows 0. That means 1 is goes to 0, no problem. But if you did this kind of mistake, if you put this one to 0, then in 0 also it should be 1, but here what you can get is 0. Why? There is a mistake. This resistance should be connected from the source to the collector, but you can see here the collector and the resistance is not connected together, right? That's why though you give 0 input to the base, LED is not turned on, right? And also you can see the base to emitter voltage VB is 0 volt. That means transistor is not getting any input from the source. Okay, how to make this okay? Just put it like this. You can see input is 0, output is 1, right? But you can still see 0 volt. Why? Why the transistor is turned off? As A is 0 volt, If A is 0 volt, there is no current flowing through the base, right? That means IB is equal to 0. If IB is equal to 0, then IC is equal to 0. That means the transistor is turned off. Okay, as the transistor is turned off, there is no current flowing through the emitter. So the current will flow through the LED. That's why LED is turned on. So now for the another troubleshooting, this is very important. Suppose first I connect the multimeter to the output terminal. You can see it's 2 volt as the LED is here. I already show you. Take out the LED, it will be 5 volt. No problem with that one. The another troubleshooting is, I show you. You see everything is same, right? No issue with the resistance, no issue. Everything is same in the circuit. Okay. Now, just recheck again. For this circuit, if I put A equal to 0, then the voltmeter will be 5 volt or the LED will be turned on, right? Now here you can see A is 0, right? LED is on, output is 2 volt. Take out the LED, it will be 5 volt, no issue. So that means A is 0, output is 1, this one is satisfied, no problem, right? But let's check this one. You see, it's still the same. But just 5 minutes ago, when I demonstrate the NOT gate using transistor, I already show you if the input voltage is 1, then output should be 0, right? But here you can see the circuit is exactly same, but A is 1, output is also 1. If you want to check, you can easily check the resistance source, connect to the source, and then connect to the first leg of the transistor. Okay, you can just check and zoom in, no problem. The base 100 ohm, 100 kilo ohm is connected with the A switch to the base, and the last terminal is grounded, and this LED is connected from the first terminal, no problem, right? But it's not working. Why? As I already told you in the first, this is collector and this is base and this one is emitter, right? As you can see, this is the transistor. If the curved surface in my side, then the first leg is the collector, then base, and then emitter, right? Here you can see that I already reversed the transistor. That means now if I reverse this one is the emitter, this one is the collector, right? That means what I did here, I just reverse it. That means this one is now collector and this one now is emitter. Okay, so if someone just reverse the connection of the transistor, then this circuit will not work. Whatever the input voltage, output will be always 1. Why? When this one is emitter and this one is collector, then this transistor is always off. Whatever the voltage 0 or 1, this one doesn't matter, the transistor is always turned off. As this is a NPN transistor and the current should be from collector to emitter. But if this is emitter and this is collector, there should not be any current. That means this transistor will be turned off. So what I need to do? If I just reverse this one, you can see, and you see is 0, right? So this one is the most important. I saw many people did this mistake, like they didn't recognize the collector or emitter in the transistor and make this kind of mistake. Okay, so if you get output is 1 volt, or output is 5 volt, or output is 1 for any kind of input 0 or 1, then just remember the transistor you connected either is the broken or you connected wrong. Okay, so this will be the troubleshooting part for the NOT gate. Okay, so that's all for this video. See you in the next one.
Thanks for your time. Please do share this concept with your friends. And if you like this video, please press the like button. It is really means a lot for me. Bye bye.